Good morning.
This paper's.
Okay, thank you. I don't know whose this is, but. Morning. But you're welcome to them because they'll get recycled, so.
Oh, thank you.
Do you need the handouts that already fit in our notebooks?
You don't have to take them, but you're welcome to them if you would like them. Hey.
My computer's been dead for a really long time.
Yeah.
I plugged it in, but it won't let me turn the power on and turn it on. I sort of wait for the hard.
Mine has done that the last 2 summers.
Sometimes I feel like there's almost like you could do a hard shutdown.
Are
and
you
then
trying to
it'll
plug it
reboot.
into the dock?
Uh-huh.
Do you have a power cord that's not the dock?
I don't know that I do anymore.
Borrow mine. Do you know if it's flat? Try plugging this in for a few minutes, and I think that gives it enough juice that you can then plug it in normally. But if it's not that, I don't know.
I didn't have the note. I didn't do them for the attendance for the AMI day, but I have them. Are those like a grade, or is it just for the attendance?
Which day?
The first, I think.
The very first day was
Yeah.
grade and attendance.
Yeah. So I don't care about the attendance, but do I need to still send those in for the grade?
If you want some points for them, yeah.
Okay.
I can't give you points if I don't see it.
Gotcha.
Okay, if y'all would please get out your limits review. It's actually going to be number 78, but I think that's the first time I've told you the number.
Good morning, thank
So
you.
please just have that out.
Monday, February 6th, 2023. Will you please join me for a minute of silence?
Is this the same review that was on your last page?
It is.
Okay.
It's just, I'll talk about it.
All right.
It doesn't hurt for you to have it. 2, 3, Alberto.
you very much. Will you please stand as you are able for the pledge? Attention to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you very much. Let's have a great day.
Okay, so as I had mentioned last Friday on our AMI Zoom, ideally we would have liked to have tested limits and moved on from that today. However, just trying to be completely fair, giving you guys a chance to ask questions in class in case you had some issues during the AMI stuff. Don't want that to impact your grade as much or as little as possible at the very least. So again, this one, I think I assigned this to you guys on Monday and then asked you on Friday to finish up the last 3 questions, but I did not tell you it was number 78 in your binder until right now. So what I need you guys to do today is to ask the questions you need some extra help on from that, so I can help you, and then you should have a good chunk of time to kind of scan over it and review and make sure that everything is ready to go, so then that way we can go ahead and test on Thursday and move on. So let me give you, I did ask you to do this as part of your Friday assignment, but let me give you a couple minutes here to start scanning through, look at your questions on page 1, see if there's any of those you'd like me to discuss again. Then start looking at the questions on page 2, start picking out the ones you want us to talk about again. That should be pretty similar in difficulty to our review. Also, so the handout this morning was the same review that I assigned to you guys over AMI. So you don't, it's not like I'm not asking you to redo it. You know, if you did it on notebook paper, you don't have to like copy it over to this. It's just that I already had those copied for us before I knew all the snow and ice was going to come. So those papers are just going to get recycled anyway. So I figured that if you could get some use out of them, it would be better for you to have them. So if there's if you want to transfer it over because you think that would be easier, that's great. If you want to use it just for some extra practice, maybe re-practice some of the questions you missed the first time, that would be great too. And if you end up not using it, then that's okay too. I guess it's the same as just recycling them. So but let me give you a few more minutes to get a head start there, and then I'll let you start asking away. Okay, so if I kind of just glance through the pages here, it looks like page 1 is mostly focused on finding left, right, and both limits from a graph. Page 2 has definitely the biggest variety of questions, finding left, right, and both limits either from a table, from a piecewise function, from direct substitution, from factoring in direct substitution, from complex fractions and direct substitution, from trig identities and direct substitution, from conjugates and direct substitution. And then we've got knowing your horizontal asymptote rules and knowing what a horizontal asymptote is, so that you can do infinite limit questions like 17, 18, and 19. And knowing the 3-part definition of continuity, and then a few examples of being able to say whether it's continuous at a certain point, but being able to justify why it is continuous or no, it is not continuous using the definition. And then that got practiced 1, 2, 3 times. And then finally difference quotient, and difference quotient from a polynomial, a radical, or a rational. Those would be the major topics to look at. Okay, so one page at a time here. So starting with page 1, trying to get a left, right, or both limit from a graph. Questions 1 or 2, either one of those two you'd like me to go back over for a review?
You do
2? Sure. So first off, you need to know, alright, well, by far the biggest misconception, and I don't know why this is just so hard for students to stick, but limits do not care what's happening at the value. So if I'm interested in the limit as x approaches -4 from the left, right, or both, I literally do not care what's happening at x equals -4. In fact, you can just flat up cover it all up and it doesn't change anything. Now that's important if you're talking about continuity, but not limits. Limits are saying what y value is it approaching. So from the left, it looks like it's getting closer to a y value of 2. Or I'm sorry, that's not the left, that's the right. From the right side, 2. From the left side, looks like a y value of -3. And if it's approaching a different number on the left than it is approaching on the right, then both, when it doesn't say left or right, wouldn't exist. But notice, when I drew my line in here, I don't even know where the point is. But I don't care. Limits don't care that the point was down here, not up here. That had nothing to do with the limit. Just what y value is it approaching. So you may even want to write that out in words if that is hard for you to accept. It's not a point. Okay, anything more specific about 2, or is that enough?
I was just making sure I got that.
Okay. I think there should be solutions on the website, so you need to check those sooner rather than later, because if you're missing a bunch, you need to know today so you know what to ask. Okay, anybody else for question 1? I mean, obviously there's not going to be like 10 of these on the test, but they can be very easy points. So even if you forgot how to do questions 1 and 2, make sure you know how to do that, because that would be easy. Okay, then page 2, I think is questions 3 through 14. And 2 of these didn't print off great. I guess this kind of depends on if you tried to print them off at home or not. But 5 was supposed to be 3 from the left, and 6 was supposed to be 4 from the right. So that's really only important so that your answer would match up the same as mine. Could be a coincidence and you could still get it right, but to me this should be the hardest page, because it's got some limits that are just direct substitution and pretty easy. Some where you've got to read a piecewise function, actually several of those. One where you've got to be able to read a table. A couple where you get 0 over 0. At least one where you have to deal with it with factoring. At least one where you have to deal with a complex fraction. At least one where you have to deal with conjugates. And at least one where you have to deal with trig identities. So this second page, with these questions all scrambled, definitely is covering the most material here. So which of these would you like a reminder on. Y'all feel okay with these? Alright, well, we probably could have quizzed today then, because again, I think that's the hardest part for sure. But there'll be plenty of time if I'm moving on too quickly, so. But let's look at page 3. So you need to know what a horizontal asymptote is. You need to know the 3 rules for horizontal asymptotes. But specifically because we want you to be able to do infinite limits like 17, 18, and 19. And that you need to understand what a horizontal asymptote is and know the 3 rules to be able to do those questions. So 15 through 19, any of these you'd like me to discuss again? What number? 16. Okay, so what a horizontal asymptote is it describes the far left, which is when x is approaching negative infinity, and far right, which is as x approaches positive infinity of the graph. So for example, if I know a horizontal asymptote is at y equals 4, that tells me as x approaches negative infinity and or as x approaches positive infinity, the y value that it's approaching, which is what limits are about, would be 4. Similar to questions 1 and 2, this is a topic that's pretty easily forgettable because it's not one that we had to work through and struggle a lot. In fact, I think you guys did the whole page of these question types in about 5 minutes the day that we did them. But likewise, if you've forgotten it, that means it's easy to pick up on. But, you know, I know things are kind of disjointed with our AMI work. So, is that the only one?
18.
18?
Yeah.
Okay. So, I would first I realized this is an infinite limit question because as x approaches infinity. So I know this is going to be the same as what it approaches as a horizontal asymptote. So horizontal asymptote, you always compare the degree of the numerator to the degree of the denominator. If the degree of the denominator is bigger, it's 0. If the degree of the numerator is bigger, it doesn't have a horizontal asymptote, so it doesn't have a limit. And if the degrees are equal, it's leading coefficient over leading coefficient. And so 3 questions because there's 3 possibilities. And that's whether x approaches infinity or negative infinity. If it was x approaching 5, then we'd work it like we would do page 2. But really, you guys, if you know your horizontal asymptote rules and you understand this guy, number 16, it's just showing you how that stuff you learned in Algebra 2 makes these questions basically the same thing. Same rules. Okay, and then 21, you do need to know all 3 parts of the definition of continuity. I don't like you guys to memorize anything, but you do need to know all 3 parts, especially because some parts will say, why is it continuous or why is it not continuous? And you can't just say there's a break in the graph or the graph jumps. Like that's fine to describe it to your friend that way, but that's not a mathematical explanation. That's not a mathematical justification. So 21, knowing the definition, or any part of 22, 23, or 24 where you were using the definition. Any of those you'd like me to go back over? 23? Okay, so for what value is this graph discontinuous? So that would look like right here at x equals -1, because there's a break in the graph there. So even though x equals -1 does have a point, there's still a break in the graph. You okay with that? Okay. So we've got 3 different types of discontinuity you need to know. A jump is when your whole graph jumps. That's not happening here. There's infinite, when you have a graph go to infinity and negative infinity and creates a vertical asymptote. Or the hardest one for students to remember is when you have a hole. It's called removable. So jump and infinite kind of lead you to what it should look like, but removable doesn't sound anything like hole, but that's what that is. Okay, justify why you think h of x is discontinuous at x equals 1 by using the three-part definition. So the three-part definition is that the limit has to exist, so it's got to approach the same thing from the left and the right. So that works. The second part of the definition is that f of that value has to exist, and it does exist. It's 4. So that doesn't prove that it's discontinuous. But the last part, what we can see visually, is that the limit, so the number that it approaches on the left and right is -3, but the point at f of -1 is not -3. -3 is not the same thing as 4. That point's, it's good that that point exists, but it's not in the right place. If this was -3, if this was moved down, then it would be continuous there. So you need something like this. You do not want to rely on explaining it in a sentence or two, because you kind of open yourself up to a lot of like counter examples and stuff. Either use the first, second, and or third part of the definition. That's why you need to know the definition. This is the third part of the definition. The limit has to equal the point. Okay, and then explain why it is continuous at x equals -3. So at -3, we can see there's no break in the graph. So to prove it's discontinuous, you only need to state one thing that's not true, but to prove something is continuous, you have to state all three things. So first off, the limit of this exists. It is -3, or yeah, it looks like it's -3. Secondly, there has to be a point there. So f of -3 needs to exist. If this isn't true, your graph is jumping. If this isn't true, your graph has a hole in it. And then the last part, which we saw was messed up about x equals -1, is that whatever it's approaching from the left and right, the limit has to be the same as where the point is. That has to be true. And then for -3, that is true. That's why it doesn't look like there's a break in the graph. So it's easy just to eyeball an x value and see that it's continuous or not continuous, but being able to say this is why it's not continuous or this is why it is continuous, that's what y'all need to be prepared for. If you know the three-part definition, then either state all three to prove it's continuous, or you state one of them that's not true to show that it's discontinuous. Okay. Questions about 23 before I move on? Yeah.
So I would work as the limit as x approaches -3 from the left and equals the limit as x approaches -3 from the right. Is that?
That's the same thing.
That's the same thing. So
Yeah,
okay.
because like up here, to answer this, these had to be the same thing. So, yeah, I mean, no, it's fine. It's fine if you either say these two are equal, or if you say that this exists or it equals a number. Any of that's fine. Because really, you're saying the same thing. So. Okay, Jacob, did you have something else?
Could you do 26 really quick?
Sure. Okay, and then the last topic was difference quotient, and honestly, I don't remember what we tested last year, and I'm not in charge of this year's test, but I would say that if there is only one difference quotient problem, and I'm not telling you that there is only one, but if there is just one, it's probably going to be a polynomial before it's going to be a radical or a rational. So you need to make sure that you're okay with this one first. So for this, you have to know what the difference quotient is. So in our AMI work, I explain a lot of that just because I want you to know that it's not random and it's not just some busy work, that it is actually leading up to something. Not for us, we're about done with this, but those of you going on to calculus, it will. Also a reminder, I'm sure I've said this, but this is about 80%, 90% of the first unit in calculus. So we're not quite done with CAP process, but those of you taking calculus next year, again, obviously you want to do well on this for this class for your grade, but also this should help make the first couple weeks of calculus go a little bit easier. The main difference is that when we do this in calculus, it's much quicker. It's like 2 weeks, but 1 day's the test, 1 day's the first day of school, so it's really like 3.5 days. So make sure that you really understand this. Okay, so anyway, you got to know what the difference quotient is. If you don't know the difference quotient, then you can't even start this. But the first part of the difference quotient says take the function and everywhere there's an x, replace it with an x plus h. So I did that in red. Then it says subtract the entire function, and finally divide the whole thing over h. So that's true whether it's a polynomial, bless you, a radical, or a rational, any of the 3 types you may see on your test. But what changes is how to simplify this. So to square this, this is the most common issue here. This is not x squared plus h squared. I don't know if this is still true, but one of our teachers we used to have here quite a while ago used to teach, I think it's iPrep. Do we still do iPrep? Okay, it's like ACT stuff. And he said that this was always something that the ACT test showed, and I don't know if that's still true or not, but they want to see if you fall into that trap. X plus h times x plus h, you actually have to FOIL that out. You get an x times x, an x times h, and h times x, so you get 2 of those, and you get an h times h. But that, for this type of question, that's the mistake 90% of the time, not actually foiling that out. You also need to distribute this 4 at some point. You also need to distribute this negative at some point. And I know it's kind of inconvenient to keep writing over h, but you do need to do that. This step doesn't equal this step if you don't put it over h. Okay, and so I FOILed this carefully, but I still didn't distribute the 2. So now I should distribute the 2. And it doesn't really matter that I don't really need to keep the coloring consistent, but just kind of showing you where those parts come from. And then a ton of stuff should cancel out if you're doing it correctly. So in our case, plus 9 minus 9, plus 4x minus 4x, 2x squared minus 2x squared. In fact, we are left with a 4xh plus 2h squared and a minus 4h all over h. And even if you think the difference quotient questions are difficult, they all have this one thing in common, and that is that you need to divide h's at the end. So notice every term in the numerator has an h, so we can factor that out like a GCF, so that our last step can be cancel out the h's, and your final answer should be 4x plus 2h minus 4. So some FOILing, a lot of distributing, a lot of combining like terms, and then GCF at the end. Yeah.
On the solutions, it says 4x plus h minus 4.
4x plus h.
Also, would you,
I'm looking at the wrong thing anyway. Was it the same starting question? Did it start off with the same function?
It was 2x squared minus 4x minus 9.
Let me double check my work real quick. 4 plus. Yeah, it looks like they're. I know for sure there should be a 4x and a minus 4. Is that what, did the answer key have a 4x?
Yeah, the answer key was 4x plus h minus 4.
Plus h? You know what, I think I probably did, there's probably a mistake on there. I don't know if that was my work or not. But when I distributed this, 2x squared, 4xh, I almost didn't distribute it to this. I don't know if you caught that a minute ago. But if I had not distributed this, I would think that was just an h and not a 2h. So that's probably what happened on the solutions. This is correct though.
why didn't you take out a 2 for that? Because like, can't you take out?
I mean, you can, yeah. If you want to also factor out a 2, you can. But these two things are the same. I don't know that this one's any better than that one, so that's why I would go ahead and quit. So, sorry, I will try to update those solutions. And then just for full disclosure, again, this, just as I talked about in the video, this does lead to a very important calculus topic. But for those of you signing up for calculus next year, it's not like we do this all semester long. Like we do it like one day in notes so that you can understand what a derivative is and where it comes from. But in calculus, we have a bunch of rules, like shortcuts that we know, so that we don't have to do this 1,000 times in one semester. Nobody wants to do all this work, but it is important to the understanding. So that's how I knew. Like with calculus, I know part of this should be 4x minus 4, just because I know some shortcuts, but I didn't know about the h part without doing all the work. So, okay, is that enough on that, Jacob?
Yeah, that's
Okay.
good.
Sorry, was it that the answer key was different?
No, I just
Oh,
needed
okay.
work through.
But for most people, I would put a star right there, making sure that you distribute or FOIL that correctly. Don't just square the h and square the x. It doesn't work that way. Okay, either of the other two difference quotient ones?
Yeah, can you do 27?
Sure. So first part of difference quotient is going to be exactly the same. You have to know what the difference quotient is. You got to memorize it like a formula. And then second, you have to apply it correctly. So the first part says plug in x plus h the first time, then subtract this function, and then put it all over h. So it's still telling you how to start it. What's different about this question type is that the simplifying is different. There's no squaring. I'm not ready to distribute or combine like terms. You got to have an idea of how to move forward on this. And the only way to move forward on this type is to multiply the top and the bottom by the conjugate of the numerator. So remember, conjugate is where you switch the middle sign only, and then we need to multiply these fractions together. And as bad as that looks, it's actually comes together okay, because if I multiply my denominators, I've got h times this mess, so I'm just going to leave that as is. Not much I can do with that. And when I multiply the numerators, a lot of stuff is going to cancel out. Partly because you're multiplying square roots times square roots, and partly because you're multiplying something by its conjugate. So the first part of FOIL, the square root of something times the square root of itself, it's just going to give you that thing. And I'm going to go ahead and distribute the 5 just so I don't have to later. You can keep up with the outer part of FOIL and then the inner part of FOIL, but they're going to be equal and opposites, and they're going to add to 0 anyway. Bless you. So you get to save yourself a lot of messy work here if you remember that about conjugates, but they will cancel out. And then the last part of FOIL, square root of 5x minus 6 times the square root of 5x minus 6 would be 5x minus 6, but it's positive times a negative, so that means it is negative. And not just the 5x, the whole thing is negative. So if I go ahead and distribute this, that makes this plus, and now it's going to finish like the last question did. Some stuff cancels, 5x minus 5x, 6 minus 6, and then the very last step is the same. Times h divided by h cancels, and you're left with the 5 on top only over this mess of stuff. I know that seems kind of weird to leave your answer so messy, but that's all you need to do. Yeah. Yeah. Sign up, take the pass, please. So to me, the end of this question, similar to 26. The start of the question, difference quotient and applying it's the same as 26. But really what makes this question different and unique is when you see something like this, knowing to multiply by conjugates is pretty much the only way to move forward. It's the only way I know to move forward. So you gotta know that that is something that can work. And it's good for y'all to see this, because it feels like just a couple weeks ago was the first time I think I showed you something where conjugates did something new for you. So it's good for y'all to see conjugates solving a different question type. And again, even if you're not doing calculus next year, first off, you never know if you're going to take calculus a few years from now, but things like multiplying by conjugates, that's a very important algebra topic. Just because you didn't do it much in Algebra 2 doesn't mean that it wouldn't come up in college algebra much. Of course, foiling, distributing, combining like terms, those are all good algebra topics. It's good for y'all to see longer questions like this as y'all build up to higher mathematics. So, okay, what else you got? Okay, well first let me point out here, truthfully, in my opinion at least, one of the hardest things about calculus is, like, if you looked at this review, the question types that you probably need some more practice on, or the question types that you're struggling with, are probably different than the question types that your neighbor needs extra help with. And short of me just making everybody do 20 of every single question type and it being like a small booklet, really the only thing I can do is just try to give you some opportunities for extra practice. So like if you struggled with those piecewise functions on page 2, I've got a direct link that lets you practice just that question type, and so you can practice a couple of them till you feel confident, or practice 20 of them if that's what you feel like you need to. Or if you feel like you're struggling with whether something's continuous or not, you might try a couple questions from each of those. But all this stuff is really just extra practice. It's not required, but it could help you out. So the review is just trying to remind you of all the stuff that we did, but you need to take the ownership and responsibility. If you know you need more practice on a certain type, then feel free to use those bit.ly links for convenience there. Okay, so you guys still got quite a bit of time, and of course I'm still happy to help you. So you've got about 44 minutes, still a little bit more than half of class. So, unless you feel like you are ready to take your test right this minute, please use this time to study, and that way as you guys come up to stuff or find things that you realize you do need a review on, I'm still here to help. So you're more than welcome to call me over to your desk and I'll come help you that way, or you can bring it up here and I'll help you. But you've got the rest of the class period to practice and study for that. So just let me know how I can help.
They just for partial credit. I didn't realize we had to do this.
Yes. You can either turn in hard copy before the test or you can put it in Google Classroom.
Okay.
Now also I've got a reminder up there. Again, I know things have been kind of disjointed, not that I would normally remind you of this, but with our test coming up, if you have any late work, something that was graded and you didn't do on time and you never turned it in, you can still get half points, but it has to be fully complete and you have to turn it in before we start the test on Wednesday. So physically turn it in before we start the test, or Google Classroom if it was a Google Classroom assignment, so whichever you prefer. And of course there's been a couple of recent assignments that I need to take up, and I'm not going to try to do that today because I don't want to accidentally take it from you and then you not have it to study. So I will for sure take up the review for a grade, and I'll probably take up 1 or 2 other assignments. So if you happen to not have everything fully completed, then you need to make sure that you do that. Put that on your list of stuff to do.
Do you have any papers for like 73 and 74?
I don't know what those 2 were. Let me look.
It's just like an assignment.
72 and 70.
Or 73 and 70. It like shows up as an assignment, so.
You can, if there's not folders in that basket over there for.
I did check that.
Okay. Check, there's a big stack of papers on the bottom of the bookshelf
Okay.
that didn't get sorted yet. The problem is some of those are multiple pages, and so until I have time to staple a few together, it doesn't make sense to put them in the folder, so.
Okay.